Okay, good day everyone. Now we will talk about impedance. So the objective here is the objective for this lesson is to introduce impedance to represent circuit components. So the circuit components or the passive components R, L, and C. So let's review that the sinusoidal form or the input signal here given this sinusoidal waveform can be represented as 5 angle 10 degrees. So the question here is how about this R capacitor and inductor, the RLC. So that is our objective, to represent that in the phasor form or the impedance form. So the cornerstones, so the basic concept that we must try to review before coming to this section is the concept of phasor, the IV characteristic of R, L, and C. So in the capacitor, try to remember that the current can be represented as C dV dt, and in inductor, we can represent the voltage in terms of L di dt. So just try to take note of this relationship of the current and the voltage with respect to capacitor and in inductor. So first, let us try to define what is impedance. So impedance is just simply the ratio of phasors of the voltage and current. So just not dili lang siya normal nga kanang ratio of voltage and current. Kaya kung normal lang nga ratio of voltage and current, resistance lang to siya. But kung moingon tag phasor sa voltage and current, mahimo na siyang impedance. So complex form na siya. So in terms of Ohm's law pod, ang voltage ma-represent na siya in terms of V is equal to Z, the product of the impedance and the current. So instead of just resistance, gagamit na ta og complex nga form, which is the impedance. Mananing ang impedance. So now, let us derive the impedance of passive components. In this section, the impedance of a capacitor. So given in a sinusoidal state, for example, that the voltage in the capacitor, we have V as a function of t equal to V cosine omega t plus theta sub V. So always try to derive this, dapat naa siya in ani nga form, in cosine form. So the derivation of that, so we have this value of the voltage, and now let us derive the current. So remember from the previous that I is a function of t equal to C dV dt. So given this voltage, we can get the derivative of the voltage. So the derivative of that, we have negative V sine omega t plus theta sub V. So the value, so we have C times negative V sine omega t plus theta sub V. So allow me, ay nakalimot ko nga, ang phasor form aning voltage is equal to V angle theta sub V. And let us continue here. So given here, kinahanglan nato siya i-represent into cosine form para ma-represent nato siya into phasor form. So from the trigonometric function, converting sine to cosine, just add negative 90. So negative C V W cosine omega t plus theta sub V minus 90 degree. So, mao na siya ang pag-represent nato from sine to cosine. Just add negative 90. And to get rid of this negative, by trigonometric function also, we just add plus 180 here. So, plus 180 para mawala ang negative. So, CV, omega cosine times omega t plus theta sub v, negative 90 plus 180 is equal to 90, so we have 90. So, the current is now represented or in the form of cosine, so we can represent the current in phasor form with I is equal to CV omega angle theta sub v plus 90 degree. So the phasor form are here. So it is summarized here. So the voltage is equal to V angle theta sub v, and the current is CV omega theta sub v plus 90. Okay. So solving for the impedance, so we have V angle theta sub v over CV omega angle theta sub v plus 90. So solving that, makancel ang V. So ang nabili na lang kay C o omega. So given plus 90, negative I na siya or 1 over J. So ang impedance sa capacitor is just 1 over J omega C. So na-derive na nato ang impedance sa capacitor. So how about the inductor? So in this form, we'll try to derive that in the phasor form of the inductor. So given the sinusoidal form of the current of that is flowing in the inductor, so we have I cosine omega t plus theta sub I. So we have I angle theta sub I. That is the phasor form of this sinusoidal current. So we have that, and the sinusoidal form of the voltage or the time domain representation of the voltage, so we have L di dt. So just get the derivative of this current. So we have negative I omega sine omega t plus t sub I. So given that, now given that sign, we cannot represent that into phasor form. So let us try to change the format into cosine. So just add negative 90 in the angle, so we can get the cosine form. So negative Li omega cosine omega t plus theta sub v minus 90 degree. So nag-add lang ta og negative 90 dire. So mana na siya. Para makuha natong negative, makancel ng negative, mag-add na po tag 180 degrees, just like what we have done in the capacitor. So V as a function of t, Li omega cosine omega t plus theta sub I minus 90 plus 180 degrees. So what we have left is this value, Li omega cosine omega t plus theta sub I plus 90. So since we are in the form na sa cosine, we can represent now the voltage in the phasor form as Li omega angle theta sub I plus 90. So in phasor form, mana ni siya 90 degrees. So Li omega angle of theta sub I plus 90 degree, and the current I angle theta sub I. So the impedance, solving for the impedance, so we have V over I, so we have Li omega angle theta sub I plus 90 degree over I angle theta sub I. So you can cancel the current, so what we have left is since 90 degree, it can be represented in rectangular form of I, so not like I dire. So what we have left is omega and L, so J omega L. So that is the impedance of the inductor. So we have J omega L. So we have derived the impedance of the inductor and capacitor. So let's now try to review the key concept of this lesson. So the impedance can be can be solved by the ratio of the voltage and the current, so the complex form of the voltage and the current. So just like the Ohm's law, we can get the voltage. So in the impedance form of the resistor is just the R value or the resistance value of that resistor. And for the capacitor, we have 1 over J omega C, and for the inductor, we have J omega L. So that's it for the derivation of the impedance of the passive components. So see you next time.